Hello guys, so I'm going to spend just a few minutes talking about temperature scales. You might think you know them already, but as I've mentioned many times, a lot of the concepts in this class seem familiar and straightforward, but there are certain aspects of them that can definitely cause issues if you're not completely solid on the concept. So I'm going to go over this one more time about temperature with you to try to remind you of some key features of temperature scales. So first of all, we are going to be using 4 kinds of temperature in this class. We'll be running into 4 different kinds. So you may not even be familiar with all of these kinds. I'm not sure. I'm pretty sure you're going to be familiar with Fahrenheit, Celsius, and Kelvin. But Rankine may not be as familiar to you. Okay, so the critical features here is that Fahrenheit and Celsius are relative temperature scales. This is very important. You do not want to deal with relative temperature scales. If you put those in the ideal gas law, you're going to get garbage. It's garbage in, garbage out. There are a number of situations like that. So you always want to take relative temperature scales and get them into an absolute temperature scale. And the absolute temperature scales are both Kelvin and degrees Rankine. And what's the difference? Well, the key difference here is that a degree Rankine is exactly the same size temperature interval as a change in degree Fahrenheit. And as you probably know, a change in degree Kelvin is exactly equal to a change in degree Celsius. The relationship between Celsius and Fahrenheit is that a change in 1 degree Celsius is equal to a change of 1.8 degrees Fahrenheit. It's also the same thing as a change in 1 degree Celsius is equal to 1.8 degrees Rankine. Because a change in degree Celsius is the same as a change in degree Kelvin, and 1 degree Kelvin is equal to 1.8 degrees Rankine. Also, a change in degree Fahrenheit is the same as a degree Rankine. So I think you're getting the picture here. Hopefully you're familiar with the concept of standard conditions, and the standard temperature is 0 degrees Celsius. That is what is referred to as standard temperature. Here's a graphical depiction of the different temperature scales. You can't get colder than absolute 0. That is the fundamental reference point for temperature scales. Because Rankine and Kelvin are absolute temperature scales, they are 0 at absolute 0. So 0 degrees Rankine and 0 degrees Kelvin at absolute 0. Whereas because Celsius and Fahrenheit are relative, they're not 0. And that's really the fundamental difference. That's what we mean by relative versus absolute. Absolute temperature scales are 0 degrees at the absolute 0 temperatures. Now, Fahrenheit, it's a very interesting history where it came up with 0 degrees. I'm not going to get into that now. But I guess what makes more sense is Celsius. So Celsius is set to be 0 at the freezing point of water, and 100 at the boiling point of water when you're at 1 atmosphere or 760 millimeters mercury of pressure. For whatever odd reason, Fahrenheit uses a very strange scale that's obviously not pinned to those 2 key landmark properties of water. Water boils at 212 degrees Fahrenheit, and it freezes at 32 degrees Fahrenheit. Now, these are the ways that you convert between the different temperature scales. And it's taking into account those 2 facts that we talked about, what the relative sizes of the temperature intervals are in the different scales, and also what they're pinned to in terms of the temperature at which water boils or freezes, or absolute 0. So, for example, it's very simple to convert between Rankine and Fahrenheit. If you have a temperature in degrees Fahrenheit, if I go back to this scale, you see that there's a 460 degree difference between Fahrenheit and Rankine. So, whereas Fahrenheit is 460 degrees, the number is 460 lower than whatever Rankine is. So, if you want to convert a temperatures in degrees Fahrenheit to Rankine, all you have to do is add 460 degrees to it. Similarly, if you want to go from Celsius to Kelvin, the difference in those two scales is 273. The temperature intervals are the same, so it's very straightforward. You just take whatever your temperature is in Celsius and add 273 to it, and that will give you the temperature on the Kelvin scale. Obviously, it's trickier to go between the two different relative temperature scales. To go from Celsius to Fahrenheit, you first have to multiply by 1.8, and then you can add 32. And that'll give you the temperature in Fahrenheit. I think it's a lot easier to just go, if you have something in Celsius, you should just go to Kelvin. You add 273 to it, and now you have it in Kelvin. To go from Kelvin to Rankine, you multiply by 1.8, because a degree Rankine is 1.8 times the size of a degree Kelvin. And then you just subtract 460 to get degrees Fahrenheit. It's basically ending up the same thing as this does for you. But for me, it just makes more sense. So let me give you a couple examples of how that would work. So what's the standard temperature in the 4 different temperature scales? Well, we know it's 0 degrees Celsius, right? So to get to Kelvin, you just add 273 to it. So standard temperature is 273 Kelvin. Well, what is that in Rankine? Well, we know that a degree Rankine, there's 1.8 degrees Rankine per 1 change in degree Kelvin. So if you multiply those two together, multiply 273 by 1.8, I don't have a calculator with me, so it should be obviously 492. And that's because I know from other ways that's what it should be. So now, what is that in degrees Fahrenheit? You'd have to subtract 460 from that. That gives you 32 degrees Fahrenheit. So standard temperature in the 4 different temperature scales is 0 degrees Celsius, 273 Kelvin, 492 degrees Rankine, and 32 degrees Fahrenheit. Okay, what's the normal body temperature? Well, the normal body temperature I remember is 98.6 degrees Fahrenheit, or 37 degrees Celsius. So to get that in Kelvin, you add 273 to that, and that's 310 Kelvin. And you would have to add 460 to this to find out what normal body temperature is in degrees Rankine. So I'm going to do that right here. Looks like it's 558.6. So we could check that if I had a calculator by dividing the degrees Rankine by 1.8. It should end up with equaling to 310 Kelvin. I'll leave that to you to figure out. But that's the rundown of how to maneuver between the different temperature scales. Temperature is essentially a macroscopic measure of the kinetic energy of the molecules at the molecular level. It becomes very important in multiple types of analyses that you will do in engineering. And I guess my main thing to remember here is not only how to maneuver between the different temperature scales, remember different landmarks such as standard temperature, normal body temperature, the temperature at which water boils at under 1 atmosphere pressure, the temperature at which it freezes. You got to know all those numbers. And always work with absolute temperature scales. That'll keep you out of trouble. Until next time.